Good morning, everybody. Happy Tuesday. It's not good to see that we have, looks like maybe 15 students out of the 33 that are supposed to be here, but we're going to get started. A couple of things that I want to start off class and make sure you guys are aware of. I'm on freeze. Next class is a review day. And the midterm exam will be your homework. So remember, the midterm exam is just going to be 10% of your grade compared to homework assignments, which are worth 80%. So next class, we're going to review everything we've done so far this trimester. And then your midterm exam is just going to be really basic questions like, hey, do you remember how to do this? The midterm exam won't be on big ideas. It's going to be posted to Google Classroom. It's just going to be a Google form. So it's the same process as big ideas. You're just going to plug in your answers into the Google form, just like you would plug your answers into big ideas. And then when you're done, you're going to hit submit. Now, I recommend doing your midterm exam on a separate piece of paper, so that way you have a paper backup. Okay? You will have 3 days to do the midterm exam. It's not overly difficult. You just have to do it. And if you don't do it, then we're in a bad place. So just make sure that you do that, okay? So we're going to start off today doing this warm-up, this algebra proof that we had for your warm-up. And then we're going to look into geometric proofs today. So really exciting stuff. All right, so let's get going. And then also a reminder that if you guys have questions, to use the chat and to turn on a mic if you need, okay? So let's get going. All right, so looking at this algebra equation, so I have my given, and I'm going to go ahead and solve this. So the first thing that I would do here is I see I have a number outside parentheses, so I'm going to distribute to everything inside those parentheses. So my second step is going to be 4 times 3 is 12, and then 4 times 4 is 16. So then, remember in our reasons here, we have to justify our steps. So what did I do here? I did the distributive property. Okay, I'm going to abbreviate property as prop, if that's okay with you guys. Save a little bit of time there. So again, I did my first step, I distributed. Okay, my next step, we can only do one step at a time. So what I'm going to do is I'm going to get all of my x's to one side. So to do that, I have a negative 4x here and a 16x here. So I'm going to add 4x to both sides. So I get my third step is 12 plus, that's going to be 20x equals 52. And then let's see here. That is, what did we do? We did the addition. And then I write POE because I did that to both sides, right? I didn't just add on one side. I added the same thing to both sides. And that's what POE stands for. It's property of equality, okay? All right, so I got here. And then the next thing I'm going to do, I want to get this x term by itself. So I'm going to subtract 12 from both sides. Step 4. Okay, so I end up getting 20x equals, and then I'm having a little brain fart right now because so much is going on. I don't know why I didn't do that in my head, so I get 40. Okay, and then I write down my reason. So what did I do here? We did subtraction. POE. Okay. And then this last step, I have 20 times x. I want to get the x by itself. So the opposite of multiplying is dividing. So I'm going to go ahead and do this. And so my last step, I get x equals 2. And then for my reason, I'm going to write division. POE, because I did it to both sides. And then I put this little box here to tell us that we're done, right? That box is like a period. Okay, so again, this is just a little review of what we were doing last class. The reason why we were doing the algebra is because it helps set up the process, right? And so what you will see even today, what we're going to do is we're going to slowly get away from the algebra, so we get more into just geometry proofs. There's still going to be some algebra, but it's not going to be like this. So we're starting out like this as it's a comfortable place, and then we're going to start doing some new stuff. So once you get the process, we'll start doing that, okay? Because we're going to be getting into more angles and sides rather than numbers, okay? So with that said, I really only one person I think has communicated with me today. Are you guys doing okay? Did this make sense? Do you guys have any questions? Do you have any questions about how next class is going to be a review and that the midterm exam will be after class? Does anybody have questions? Oh, thank you. I appreciate that. That's so lovely you turned on your mic. Thank you so much. All right. Well, hey, you might be late, but what matters is that you're here, and I'm glad that you're here because when you're here, you're going to be able to do great things. So I'm glad that you're here. Also, remember, I know technology issues happen. I'm live streaming to YouTube, so this video will be up on YouTube. So if you missed anything, like for example, all the announcements I made at the beginning of class, then you can go to YouTube and watch that later. Okay? All right. So we're going to be doing geometric proofs. That's what we're doing today. Now, remember, we talked about deductive reasoning, right? We spent some time on that. So deductive reasoning means we use rules, we use laws. And that's just like any time you think about it, like you play a game. There's always rules to a game. So we can't play the game unless we know the rules. So what I'm going to start with is I'm just going to make a list of all the rules that we have. Okay? Now, I'm not going to go through and reteach every single one. We don't have time for that. So if I write something down, you're like, what is that? You can either look at your notes, you can Google it, you can email me, or you can come to my office hours. Okay? So let's take a look. So we're going to have, here's our reasons. And now remember, our reasons are our rules. Okay. And right, these are going to go in the reason column. Okay. So the one specifically for geometry that we've seen so far, what do we have? We have reflexive. We have symmetric. We have transitive. Yeah, what's up? I mean, I would definitely write this down. So a good rule of thumb is you should write down anything I write down, and you should also write down anything that I say that's important. So when taking notes, and I know you guys don't ever take a class on taking notes, right? You should always and it doesn't have to be like, for sometimes, like if a teacher writes down like a big paragraph, unless the teacher's like, you need to have this down word for word, you should summarize it, right, in shorthand. But when you're taking notes, you should always take down, especially if it's not long, like this is a list, you should always copy that down. And then like if I say something about this list and you're like, oh wow, or like, oh, that's good to know, you should write that down as well, right? So you kind of are thinking, listening, and then in your head, if something's like, that makes sense, you should write it down, because the future you might not remember that. So that was a good question. Thank you so much. Okay, so we talked about these last time, right? Reflexive, symmetric, transitive, and those were on your homework as well. So some other ones we had, right? Some older ones. We talked about supplementary. And then complementary. We talked about angle addition. We talked about segment addition. We talked about midpoint. We talked about bisector. Okay, so again, these are just all things that we've talked about in geometry that are rules, right? Like we talked about, you can add things. Supplementary meaning two angles that add up to 180. Midpoint, bisector, right? Things are being cut in half, two equal parts. Oh, and then the last one, right? Given is always how we start, right? So I think for right now, that's our list. Now, just a heads up, as we keep going throughout this trimester and next trimester, this list is going to get bigger, right? So it's super important that we get to know this list now, because as we go further and further in geometry, we're going to be adding more stuff, right? Every time we learn something, we can use it, right? And that's true in life, right? Every time you learn a skill, you add that to your little bag of tricks. So then when something comes up, you can be like, oh, I learned this skill, I can do this, okay? So this is kind of just our little bag of rules. So when we're proving things, these are all things we've learned that we can use. Now, obviously, some other things that aren't on this list are all the algebra stuff, like adding, dividing, multiplying. Ooh, I should add that one, substitution. I knew I forgot one. And then the other one is transitive. I knew I forgot a couple. There we go. These two go hand in hand, right? It's kind of, right? Transitive property is that chaining. We chain a whole bunch of things together, and then substitution. Okay? All right, excellent. Again, so as we keep going forward throughout the year, I'm going to keep adding to this list, right? And it's an informal list, but the idea is anytime so again, I'm going to put distribution in with all the algebra stuff. Does that make sense? So distribution, multiplication, division, adding, subtracting. It's all stuff we should know, but I'm not going to include it in this list because it was a previous class. So that was a good point. Thanks for doing that. Okay. All right. So what we're going to do is we're going to do, the way that we're going to do this is I'm going to do 2 proofs for you, so you guys can see the process, you can ask questions, and then we're going to end with you guys doing 1 proof. And then I'm pretty sure your homework is like 5 questions. And you're going to do some just using properties questions, and then there's going to be, I think there's a fill in the blank proof where you're just going to say what the reason is, and then I think there is 1 proof where you're going to do it all on your own. Okay, but I think with WebAssign, it's just fill in the blank. So, all right. So what we're going to do, so with any proof, what you're going to find with geometric proofs is you're always going to have a diagram, a given, and what you're trying to prove. So here is my diagram. So I'm going to have a segment, and I'm going to go S, T, and U. A little stew going on, brewing it up. Little warm stew. And then I'm going to add in some algebra, because again, we're going to start out with algebra and we're going to move away from algebra once we've gotten comfortable with this. Okay, so I have 7x and 3x plus 20. Okay, and then my given is going to be point T is the midpoint of segment SU. Okay, so point T is the midpoint of segment SU. That's going to be given. And then what we're going to try to prove is that x equals 5. So again, we're going to have some algebra in this one, right? So we're transitioning from algebra to geometry, but we're introducing more geometry. Okay. So to do this, right, gosh, there's a lot of setup for proofs, isn't there? I'm going to make a 2-column proof. So I'm going to have statements. I'm going to have reasons. And then this is my setup. I have a diagram. The diagram is going to be super important, right? Because it's going to be visual based. So we want to be able to look at it and see what we can see. But remember, we can't, this isn't an accurate diagram, right? So this diagram isn't accurate. It's just a tool for us to visualize what's happening. And then our given, and then we're going to have our end. Okay, so how do we always start proofs? Can you guys type that in the chat? What do we always start with? What always comes first? Yeah. Ooh, yeah. Good stuff, guys. Yeah, so our given comes first. So I'm going to take this given right here, and I'm going to write it down as my first one. Okay, and you can't abbreviate the given. Have you guys ever heard of the saying, the customer's always right? If this is what the customer gives you for the given, that's what we're going to use. So I'm going to say point T is the midpoint of SU. And notice here, right, I'm going thick. That's why we label our steps so that we can always line them up. Right? So that's my given. Okay. So there's my given. So now, again, I really want you guys to make sense of this, because someone asked a great question earlier, like, what do we take notes on? Are we writing this down? So as we go through this, I just want you to know this isn't like algebra. In algebra, your teacher could do a problem and then give you a problem that looked just like it, and you'd be like, oh, I can do this. In proofs, I can't do that. That doesn't make sense. Why would you guys do a proof that we've already proven? That would be a waste of time. You guys see what I'm saying? That'd be like me building a deck and then me tearing down that deck and then saying, all right, now you build it. Right? That's not how it works. We build it together so that you can then go somewhere else and build your own deck. Okay? So what you should be taking notes on is the process. I'm going to think out loud, and you should be taking notes on, okay, what's Kref doing? Why is he doing it? So that you can know how to do that next time. Does that make sense, guys? So it's like building a deck. I'm not just going to build it, have you guys watch. I'm going to be like, this is why I'm doing this. This is why I'm doing this. So that way you guys can go build your own deck. All right, cool. So this is what I'm going to do. The given, so we want to get x equals 5, right? So doesn't that mean we need an equation? We don't have an equation in our proof. We need an equation, right? We need an equation that has x in it, because we need to get to x equals 5. So a pro tip, so again, this is what I'm doing. I always start by looking at the answer and seeing what I need. So you could write that down in your notes. Start by looking at the answer and say, hey, what do I need in my proof? Well, I need an x, right? And I need an equation. So where can we find that? Well, the given is always a great place to start. So look at the given. It says point T is the midpoint. So you have to think, what's a midpoint? Well, duh, T's in the middle. But remember, that's not what we want to remember for midpoint. If T's in the middle, that means the left side, ST, is going to be the same as the right side, TU. And that's an equation, right? There's going to be two equal parts. Now, I just want to give you guys a little heads up. If you're following along in the book will do it purely geometric. It will say the left side, ST, is congruent to the right side, UT. Sorry, that's a U, not a V. Okay, and then they'll say, and then the book will say definition of midpoint. Now, I'm just going to go right off the bat, and I think this is a waste of time. So I'm going to go like this. Okay, but I'm going to cross it out, not erase it, because the book will do this. And I think this is a waste of time because this is so formal. You guys will probably never write a formal proof. And if you do, it's going to be in like your third year in college, and you won't remember this conversation. Okay? So with that said, I just wanted to show it to you. But really what we're going to do is we're going to dive right into the algebra that matters. So instead, my second step is going to be the left side equals the right side. And I'm writing definition of midpoint. Hey, and guys, we're so new into proofs that if you just write midpoint, that's okay for right now. You know what I mean? Like, don't worry about the verbiage or like what words are going in. You just want to get, do I have the right idea? Okay. So again, I knew I needed an equation with x in it. I see I have a midpoint in my given. That gives me an equation. The left side is going to equal the right side because that's what a midpoint is. That's the definition of a midpoint. Okay, and then what's cool at this point, the geometry is over and we're going to go into some algebra. So I would start by subtracting 3x from both sides. So I'm going to get step 3. I'm going to get 4x equals 20. And what did I do here? I did subtraction. And I did it to both sides, so I write POE. Okay, and then I'm going to divide by 4. So my last step here is I get x equals 5, and my answer is, or my reason is division POE. Okay, so these last two steps were just algebra. So as you can see, what really here, this one step that I made black, right, to kind of highlight it, that was the geometry bit. Now, there wasn't a lot of geometry in this proof, but the geometry that was there was super important, right? And that was the idea of using a midpoint. So we used a midpoint to set up an equation that we then could solve, okay? So as we're starting out in proofs, that's going to be a lot of what our proofs are going to look like. We use geometry to set up an algebra equation so that we can solve. As we get further and further, it will just be pure geometry, okay? But right now, we're just kind of easing our way into geometry. So, hey guys, that was it. Does anybody have questions or comments or concerns? All right, I appreciate. Hey, any feedback, even saying nope is fine. A lot of people are using the direct message and chat. That's wonderful because then that way you're just talking to me and you don't like if you're like, oh man, I'm really confused. People don't need to know, and I'll never say your name. So, if you send me a direct message. All right. Hey, and I really appreciate you guys. Thank you for the feedback. Because remember, your feedback is all I have to direct class, right? So if you guys are doing great, then we can just surge ahead and do stuff. But if you're not doing well, then we need to hit the brakes. All right. So again, like I said, we're doing a couple of proofs. So that was the first one. So hopefully you guys took notes on that. Hopefully you were like, okay, I start with my given, I look at the answer, and I say, what do I need? Right? And then you're like, okay, I know I need these things in my proof. How do I get them? So the given usually is a good starting place for that. So let's do another proof, and let's see if we can't use some of those techniques. So I know I'm going to have a T-chart here, a 2-column proof, statements, reasons. This is just a nice visual way of doing proofs. That's why I do them like this. There's other ways to do these proofs. We're going to talk about that next class. Okay. All right. Here, let's do one with angles. Ooh. So I'm going to have a little upside down V, and then, so let's see here. I'm going to put arrows on those, and I'm going to label this L, P, and N, and then the vertex up here, I'm going to call that M. Okay, so this is my diagram, just like an upside down cone, or just a cone. I guess that would be right side up for a cone. And then a ray going down the middle. We're going to have a given, and it's going to be that ray MP. So ray MP bisects angle LMN. Should make that a capital M. Okay, so ray MP bisects angle LMN. So as you can kind of see already, this problem is going to be very similar to the last problem. The difference is we're taking out the numbers. Okay, so the last problem we had a lot of numbers in it. We had X and stuff. This problem is going to have no X, no numbers. Okay, so again, we're working to just geometry. And this problem right here is just geometry. So what we're going to prove today is we're going to prove that 2 of angle LMN MP equal 1 angle LMN. Okay, now this is very simple, and some of you might think silly proof, but again, we're practicing doing a geometry proof without algebra, right? So again, these proofs are going to be really basic, and it's going to be like, well, duh. Some of you are going to look at this and be like, I get that. But that's okay. We're just practicing. We're doing the format. We're getting you guys comfortable, so everything will be smooth later on. Okay? All right. So again, where do we start? We always start with our given. So I'm going to write statement 1. I'm going to have ray MP bisects angle LMN. Okay? And my reason is, well, Mr. Kreft just kind of gave it to me and ruined my day. I mean, don't write that out. Just given will convey the same message. Okay? All right. So we're going to do the exact same thinking, and hopefully you guys are writing down this notes, especially if you're taking Cornell. If you're an avid student, right? You have that margin. This would be a great place to put stuff in the margin. You don't have to put just questions in the margin, right? You can put like eureka moments, like, oh, that makes sense, right? So I've gotten start. This is what I call a start. I have my problem down. I have my given down, right? Because the given is given. You didn't do it. We haven't done any work yet. So I'm going to take a look at what am I going to try to prove? Well, I need 2 angle LMPs, and I need 1 angle LMN, and I need an equation. Okay, so I need both of these in an equation. And if I look at my proof, I don't have an equation. So for me, my first thing that I want to do is, 1, I want to get at least in 1 equation, and 2, I need to get an equation that has LMP in it and LMN. Okay, so I need an equation that has these in it. So that's what I'm going to do. Now, last time I said the given gives us a really good indicator. So bisect. Bisect means to cut in half. So if I look here, right here I have MP is bisecting LMN. So that's the big angle. It's being cut in half. Well, if it's being cut in half, shouldn't there be 2 halves? There should be 2 smaller pieces that are the same. So in my picture, right, that's going to be this angle and this angle. And I'm just using the same symbol for both angles to show that they're the same. So that would be angle LMP is congruent to angle NMP. And in fact, I'm going to go ahead and I'm going to write that down. Okay, I'm going to say angle LMP is, I'm going to say equal just to keep things, I'm just going to keep things simple for you guys, and we're not going to talk about the difference between congruent and equals in proofs. Angle NMP. So I apologize. I am kind of lying to you just a little bit, just to make things easier. But you guys will be fine, because again, if you're ever going to do formal proofs in your life, you won't remember this conversation. All right. And then 2, how did we know these 2 angles are congruent? Because it said bisect. So that is literally the definition of bisect. Okay? Now, if you wrote definition of bisect or right, I'm not going to get upset about this. And with big ideas, right, it's going to have a drop down, and you just find the one that has bisect in it. Okay? All right. So let's check how we're doing. So I needed an equation. Yep. I need 2 LMPs. Well, I only have 1 LMP. So, all right, it's a start. And then I need LMN. Well, I don't have LMN as an equation. Okay, so that's the next thing I need to do. I need to get LMN in here somewhere. So if we take a look, LMN is this big angle. Now, we wrote down all our reasons for proofs, right? So how can I get an equation in there? Right? So I'm like, no. Supplementary, well, we don't know what they add up to, right? Angle addition. So isn't that the bigger angle? So what does angle addition say? Angle addition says that if I have a big angle, then any smaller angles inside of it should add up to that bigger angle. Ooh, let's do that. Let's do that. So I'm going to have, let's see here, step 3. So my bigger angle, angle LMN. Okay, I'm going to hit pause for a second. Does this make sense what I'm doing, guys? Does it make sense that I need an equation? I need this, right? I don't have this yet in my proof. And I'm doing angle addition. I just want to make sure because this is new stuff, right? It's not algebra, right? This is just geometry. Okay? So it's going to be the big angle is going to be the sum of two smaller angles. So that would be angle LMP plus angle NMP. Sorry, I kind of ran out of room. That's an M right there. And then what's my reason? Well, I did angle addition. Right? Two smaller angles of a big angle are going to add up to that. Okay? So again, I'm going to recap everything I just said. So I started out with my given. I looked at, remember, this is my end, right? So I'm reverse engineering. I know I needed an equation with LMP and I needed an equation with LMN. Well, using the given, and you're almost always going to use the given, I started out with bisect. Bisect means cut into half. So there's going to be two halves, right? And if you have two halves, that means they're the same. So I started with that, using the given, saying definition of a bisector. And what that gave me is that gave me an equation with LMP in it, okay? Then I was like, hey, I don't have an equation with angle LMN in it. So angle LMN, right, is the big angle. So I was like, oh, that big angle is really just the sum of those two smaller angles, okay? So now what I've done is I've accomplished this. I have an equation, and I have both of these in an equation. So let's take a look what I want. So I want LMN equals 2 LMP. Well, right here I have LMN equals 1 LMP, but then I have this, right? So I don't want NMP in here. I want this to be an LMP, right? So what I'm going to do is notice this. What does this equal? Right here, angle NMP equals LMP. Okay. Now, one place people make mistakes is, remember, you can name angles multiple different ways. So what I see people sometimes do is they, instead of calling it NMP and NMP, they call it PMN and NMP, and then they don't think they're the same angles. So when you're doing proofs, it's really important that when you name something, you use the same name for it over and over again so that you know they're the same. Because when I'm stressed and I'm doing a proof, if I name these the same angle two different ways, my brain might not register they're the same angle. Okay, so what I can do here is I can substitute angle NMP for an LMP because they're the same. So I'm going to have, so this is going to be a substitution. So I'm going to have angle LMN, see how that's staying the same, equals angle LMP, that's staying the same, and then plus angle LMP. So I replaced NMP with LMP. And why could I do that? I did that using substitution. I forgot a U in there. I'm so sorry. Okay, so I did substitution. And again, what we're doing here, right, is we're replacing that with that. I'm just trying to highlight my work. Okay, and then let's take a look at what we have. So I have angle LMN, that's what I wanted, equals LMP plus LMP. Now, it's not written like they want it, right? Remember, the customer is always right. So what we're going to do is we're just going to take our last step to say, hey, angle LMN, how many LMPs do we have? 2 angle LMP. Okay, and in algebra, what did we call that when we took two things on one side and brought them together? I'm trying not to say it. Yeah. And in this case, we don't have variables, so I would just say combining like terms. So I would say combining like terms. And then if you use the words terms, then it doesn't have to be variables or constants or angles. It can just be whatever the terms are. All right, so now I imagine some of you were like, whoa, this one was a bit more difficult because it didn't have all that algebra that we're comfortable with, right? So does anybody have questions about this proof? Does anybody have questions about the process, how I thought about it, how I did it? Because in just a second, I'm going to have you guys try a proof on your own. You guys have me worried a little bit. So I have two. You're my fourth period geometry. I also have a second period geometry. And in my second period class, like they were asking all sorts of questions. So I'm worried because it could be that you guys are just like, Kreft, we got this. Or you guys could be like, Kreft, we're so confused, I don't even know what to ask. Or you could just be like, Kreft, I'm playing Fortnite with my brother in the other room, and I'm not even in the room listening to you. I mean, all of those could be true, right? So, hey, and for the people... All right. So, let's try one. I agree. Yeah. And thank you guys. I want you to be good. I want you to feel good. You know, that feeling in math when you don't get it, that's the worst feeling ever. And I don't wish that upon anyone. So, okay. So you guys are going to try one on your own. And we're going to see where you are. Okay? So, we're going to have a 2-column proof. We got to have a picture, don't we? So our picture, I'll do it in red so it stands out. So this is going to be a segment proof. So we're going to have segment AB. And you can tell my segment isn't perfect. Don't worry about it. We're going to have a point M. And we're going to have a given. And our given is going to be point M is the midpoint of segment AB. We're going to prove that segment AB is equal to 2 of segment AM. So this is a combination of the last two proofs, right? So the first proof we did something like this, but it had a bunch of algebra in it. In the second proof, it didn't have any algebra in it. So I want you guys to copy this down and to try it on your own. Now, I'm going to give you hecka time to do this, okay? So if you finish early, check your work. Use it to maybe get a drink of water or a bathroom break. But I'm going to give you 5 minutes to do this because we all work at different speeds, and that has nothing to do whether or not you get it. So I'm going to give you guys 5 minutes to do this. During these 5 minutes, if you want to ask questions, you can send me a direct message or you can turn on your mic. But this is time to get this done. It's really your first proof that you're doing. That's your first geometry proof. So I want you to take time, make it work. Okay, so we're going to get 5 minutes here. And again, if you have questions, let me know. And remember, if you guys are stuck, if you have questions, you can ask for help. Hey, it's yeah. Hey, it's okay. So if you run out of room, see how we're numbering our steps? It's okay to just make a new T chart somewhere else and then just start the numbering off where you left off. And that's another reason why we number, so that you can't do that. Oh, I didn't have my mic turned on. So if you run out of room, the really nice thing that we number our steps is that you can just go on a separate piece of paper and draw a new T chart and just continue where you left off with your numbering. So if you only get to step 3 here, then you can just make a new T chart and start in step 4. And then for this problem, you don't know where to start? Okay. Well, so in this case, did you get down your given? Okay. So then what's a midpoint mean? Okay. So we need an equation that has AB in it and an equation that has AM in it. So a midpoint says it's in the middle. That means the left side is going to be the same as the right side. So is that something we can write down in our proof, that this left side equals the right side? So give that a shot, right? And then another thing, so then write that down, and then go back to your end thing and be like, do I have both of these in there? And if you don't, like for example, if you don't have segment AB in there, then you're going to want to get an equation that has segment AB. So if you get stuck, I would recommend looking at the reasons, because there's only so many reasons we can use. Oh, we're almost out of time. Do you guys want more time? Can you guys tell me in chat? Do you guys want more time? I will. So if you finish good, I'm just going to give 2 minutes extra time here. All right, so unfortunately, due to time constraints, we do need to move forward now. So I'm going to go over this, and if you weren't able to get to the end, that's okay, right? I'm not expecting you guys all of a sudden are proof masters. Okay, so what we do, and proof master isn't a thing, I just made that up. So what we do need to talk about is, if you did get stuck, why did you get stuck? And then how can you get unstuck, right? Because being stuck in math is the worst feeling ever. So if you were stuck, try to identify where you got stuck and then take notes on how I get unstuck. It's the process, not the actual answer, because again, we're not going to do this problem again. Okay? So it's what was I thinking? How did I do it? What was the process? So again, I look at the answer first, right? And I'm saying I need an equation that has AB in it and AM. So the first place I'm going to look for is my given. My given will always give me something important, or else it wouldn't be a given. We would just ignore it, right? So the given is always our best starting point. So a midpoint, yes, it means in the middle, but it means the left side then is going to be the same as the right side, because that's the definition of a midpoint, is that it's in the middle, so the left is equal to the right. So I'm going to start by saying that the left is segment AM and the right is segment BM. Now, if you wrote MB instead of BM, that's totally fine. Just be consistent when you're doing your proof, okay? So what I did here is definition of a midpoint. And in proofs, guys, after you write down the given, there's usually going to be a free one, right? So that it's going to be write down your given, and then your given gives you something new. That's going to happen a lot. So always look for your given to give you the next step. So now let's take a look at what we have. Well, I do have an equation with AM, but I don't have an equation with AB. So AB is a segment. Okay, but I notice AB is a large segment and there's two small ones inside of it. So I'm going to use angle addition. I'm going to say, not angle addition, segment addition. These are segments. So segment AB is actually the sum of segment AM plus segment BM. Now, notice how I'm just being consistent with how I named that segment. If you called it MB, you would call it MB here. Don't switch them, because then you won't think they're the same. Okay, your brain, your eyes play dangerous tricks on you, because your eyes are looking for patterns, right? It's doing that inductive reasoning, and it won't see that they're the same. Okay, so what did I do here? I did segment addition. Okay. All right, so let's check. Do I have an equation that has an AM in it? Yeah, I got two equations, which is good because I need two AMs. And do I have an equation that has AB in it? Yes, good. Okay, so I call this kind of like a creation phase, right? I've created the equations I need, so now I just need to combine them to get the answer that I wanted. So I want AB to equal 2 AM, but right now I just have AB equals 1 AM plus this thing I don't want. So if I can, I want to replace this. So luckily for us, BM equals AM. Now, while we're doing this, another thing I want to say, the order of these two doesn't matter. So if you did this one first and this one second, that's totally fine. Okay, you guys, does that make sense, guys? The order of these two blue steps doesn't matter. You could have done step 3 first and step 2 second. Okay, so all that matters is that you have them. The order doesn't matter because you need both of them to be able to combine them. So when I combine them, right, what I'm going to do is I'm going to replace BM with AM. I'm going to get segment AB is equal to segment AM plus segment AM. And what we did here was substitution. Okay, and then, oh my gosh, don't we have two AMs? But it doesn't quite look how they wanted. So I'm going to have one more step that says segment AB is equal to 2 segment AM. And this is just like the last problem. We're going to say we're going to combine like terms. Okay, and then I'm done. And this is why the box is so important. If you have multiple 2-column charts, right, you want to put the box when you're done. Okay. All right, so that takes us, so I do have a couple of announcements. Don't peace out just yet. So a lot of people weren't here at the beginning of class. Make sure you guys are getting here at the beginning of class. Try to get here before class starts because then you get a chance to work on the warm-up, and that's extra practice. Next class, the next time I see you, which will be Friday, it's going to be a review class. We're going to review everything that we have done this trimester. Then your homework won't be homework. It will be a midterm exam. It will be on Google. It will be a Google form. So it's the same process as Big Ideas where you put your answers in and then when you're done, you hit submit. With your exam, I really strongly suggest doing all your work on a piece of paper in case something wonky happens. You can always be like, hey, here's my work and here's my answers. Okay, so that's going to happen next class, and I'll remind you guys of that next class. You'll have 3 days to do your midterm, just like you would an assignment. It's not any longer than an assignment. Okay. Another thing, I've had a lot of questions. No, I don't penalize late work. If you guys have missing assignments, you need to get those in. Your assignments are 80% of your grade. This midterm is only 10%. Assignments are super important for you passing this class. If you guys have not done assignments, make sure that you go ahead and do that. Make sure, again, on Big Ideas, you have to click submit before it to be turned in. So if you've been doing assignments and not clicking submit, you haven't been turning in your homework. Please check Skyward for missing assignments. If you guys turned in an assignment and you got a low grade, you can always redo any assignment. You just have to email me and say, I would like to redo this assignment. I'm in this period. Okay, and then I can go unsubmit it, and then you can do that. Okay, does anybody have questions about that?